The Mediterranean stretched endless below, a glittering expanse of blue and green that had become as familiar to Lieutenant Fritz Weber as the taste of cockpit air. June 12th of 1943, a date that would reshape everything he thought he understood about warfare, engineering, and the gap between American innovation and German calculation. His compass had begun its betrayal somewhere over the open water, the needle wavering like a drunkard's hand before settling firmly toward what should have been Allied Sicily. Through the P-38 lighting's sleek canopy, Weber's eyes caught the unmistakable geometry of an airfield materializing through the heat shimmer below. Concrete runways arranged in the familiar checkerboard pattern. Control tower standing sentinel. Aircraft dispersal areas matching the briefing photographs perfectly. This had to be it. This had to be Katanya. Relief flooded through him for exactly 4 seconds. Then his eyes focused on the threshold markings. Black crosses, swastikas. The Nazi insignia painted bold and brazen across German concrete. Not Sicily, not friendly territory. Somewhere deep in enemy-controlled Italy, his damaged fighter was running on fumes. The fuel gauges told a story of hours already spent hunting Messerschmitts over Naples. His port engine had been hemorrhaging oil since that encounter, temperature creeping steadily into the red zone despite every careful adjustment he'd made to mixture and manifold pressure. The Allison V12 engine was dying, probably damaged in the accessory section, and basic mathematics suggested maybe 10 more minutes of operation remained before metal and oil combustion ceased entirely. His starboard engine still turned strong, but flying a twin-boomed fighter on a single engine meant descending at 200 feet every 60 seconds. He wouldn't reach friendly lines. The simple arithmetic was inescapable. Weber keyed his radio anyway, calling out his position to friendly controllers who couldn't possibly help him now. Static answered back. The German airfield below offered the only realistic chance at survival. He'd trained for this scenario back in training command, instructors speaking calmly about surrender procedures and enemy interrogation resistance. But those classroom exercises hadn't captured the gut-wrenching reality of piloting $20 million worth of America's most advanced fighter directly toward swastikas. He began his descent, hands moving through emergency procedures burned into his memory through countless training hours, mixture controls rich, propeller governors high RPM, landing gear extended and locked, flaps to approach position, each action mechanical, methodical, a soldier following the only script that might preserve his life. As Weber lined up on final approach, his damaged port engine finally surrendered. The grinding metallic shriek tore through the fuselage like a banshee's wail. The Lightning lurched violently left as asymmetric thrust seized control. Weber's right boot pressed hard against the rudder pedal, body tensing against the flat spin that wanted to claim him. His left hand smoothly reduced power on his remaining engine. The twin-boom fighter straightened. Hostile runway and approaching fast at precisely 130 knots. Textbook speed for a crippled P-38 making its final approach. German ground personnel had already broken into desperate runs toward the runway. Mechanics, supervisors, officers emerging from various buildings. They'd glimpsed American twin-boom fighters only through gun camera footage before those formations turned their own aircraft into flaming comets. This was their first encounter with an intact specimen. The P-38's main landing gear kissed concrete with barely a whisper. The aircraft settled onto its tricycle gear with the smooth precision that Lockheed engineers had designed into every system. Weber held the center line, using differential braking to maintain directional control as his airspeed bled away, velocity dropping from 90 knots to 50 to 30 as the fighter's momentum surrendered to friction and gravity. At 50 knots he worked through his final cockpit procedures, mixture control to cutoff, magneto switches off, master electrical switch off. The Lightning's remaining Allison engine wound down with a diminishing whistle, propeller blades slowing from their blur into individual spinning rotors, then finally to silence. Real silence, the kind that made ears ring and minds race. German voices erupted in shouted orders, words Weber couldn't understand, but whose urgency he felt viscerally. The canopy slid back on its rails with a pneumatic hiss. He stood slowly, deliberately, raising both hands above his head in the gesture understood across every human conflict. Surrender. No resistance. No threat. Wehrmacht soldiers approached with weapons trained on his chest, yet their eyes kept drifting toward the P-38's unusual configuration. The twin booms, the nose profile unlike anything German aviation had produced. A German officer, distinguishable by the insignia on his collar, stepped forward and addressed him in heavily accented English. "You will surrender your maps and radio codes immediately." Weber nodded and reached carefully into his flight bag. The canvas pouch containing navigation charts and frequency crystals came free. These materials were classified, yes, but Weber had trained for this reality. He scattered the papers across the cockpit floor and struck a match, watching months of operational intelligence curl into ash. The radio codes required simpler handling. The quartz crystals came from their protective foam case and fell onto concrete. His boot heel ground them into glittering powder. The Germans could have his aircraft. They would not have the frequencies connecting every P-38 squadron from Algeria to Italy. As German soldiers escorted him away from his fighter, Weber took one final look. Serial number 432278 sat on the enemy runway like some sleeping predator. Twin booms gleaming in afternoon sun. Nose-mounted cannon barrel protruding from that distinctive profile. This aircraft had carried him through 43 combat missions without a single mechanical failure. Every switch, every gauge, every control had become as familiar as his childhood bedroom, the kind of intimate knowledge that made pilot and machine almost indistinguishable. The turbo superchargers maintaining full power at altitude, the counter-rotating propellers eliminating torque roll on takeoff, the tricycle landing gear making ground handling safer than anything in German inventory. These weren't exotic technologies to Weber. They were simply the way American fighters worked. Engineering solutions to operational problems, choices made by designers who thought differently about what an aircraft should be capable of achieving. But as Wehrmacht vehicles surrounded his captured Lightning, reality struck with full weight. He hadn't simply delivered a single fighter aircraft to German intelligence. He'd handed them a complete technical education in American aviation philosophy. A design approach prioritizing operational effectiveness over theoretical elegance, redundancy over weight savings, pilot survivability over manufacturing simplicity. The Germans would soon understand that capturing a P-38 Lightning meant capturing the future of military aviation itself. The Rechlin test facility erupted with hydraulic grinding as ground crews positioned the captured P-38 for systematic disassembly. June 18, 1943, marked the beginning of the most comprehensive aircraft evaluation in Luftwaffe history. The facility hummed with barely contained excitement and professional rigor as German engineering's finest turned their full attention toward American innovation. Oberingenieur Wilhelm Schmidt approached the American fighter with methodical precision that had earned him recognition throughout German aviation circles. Leather notebook in hand, slide rule clipped to his breast pocket. Measuring tools arranged with Prussian orderliness across his workbench. Schmidt had devoted 23 years to the precise art of aircraft weight reduction, eliminating every unnecessary gram from German fighters through careful engineering compromises that sacrificed redundancy for efficiency. His supercharger systems for the Bf-109 represented the pinnacle of lightweight philosophy. Single-stage centrifugal compressors boosting engine power while adding minimal structural complexity. The American approach, revealed as his team removed the P-38's engine cowlings, violated every principle of rational design thinking that Schmidt had spent decades perfecting. Twin General Electric turbo superchargers dominated the Lightning's aft fuselage sections, each unit weighing over 200 pounds, spinning exhaust-driven turbines at 22,000 revolutions per minute. Schmidt's assistant, Lieutenant Karl Brenner, recorded specifications that seemed deliberately wasteful by German standards. Cast aluminum housings thick enough to withstand pressures that would destroy conventional superchargers. Intercooler cores built into the wing leading edges with hundreds of individual cooling tubes. Wastegate controls operated by automatic aneroid capsules that regulated boost pressure without requiring pilot intervention. Petrograd, Brenner said, consulting his measurement notebook. Each turbocharger system weighs more than our entire supercharger installation on the BF-109G. Yet somehow they maintain full power to 12,000 meters altitude. Schmidt knotted his brow, understanding implications that rippled through German fighter doctrine. German aircraft lost significant performance above 8,000 meters, forcing Luftwaffe tacticians to accept inferior operational ceilings against American bomber formations that could climb higher and stay longer. The disadvantage had shaped strategy and tactics for months. The propeller examination proved equally disturbing to German engineering assumptions. Schmidt studied the Lightning's nose sections where Curtiss electric propellers mounted in opposite rotation directions, port engine turning clockwise when viewed from behind, starboard engine counterclockwise. This configuration eliminated the torque roll, plaguing single-engine fighters during takeoff and climb phases, allowing even inexperienced pilots to fly hands-off during these critical flight segments. German doctrine emphasized pilot skill compensating for aircraft limitations through superior airmanship. The American philosophy embedded in every Lightning system assumed average pilot capabilities and compensated through engineering sophistication. Schmidt's calculations revealed the weight penalty. The counter-rotating propeller system added over 400 pounds compared to conventional installations, yet provided operational advantages that German training methodology couldn't replicate. Schmidt's technicians methodically removed the aluminum skin, laying bare the P-38's intricate mechanical world. As each panel came away, the sheer density of systems became impossible to ignore. Hydraulic networks ran throughout the airframe, powering the landing gear, control surfaces, and dive brakes through an elaborate system of pressure lines with multiple redundant pathways. The electrical architecture alone was staggering. Dual generators, backup voltage regulators, and battery systems safeguarding every critical instrument. The fuel system embodied this same philosophy of redundancy and survival. Boost pumps worked alongside transfer pumps, while cross-feed valves allowed either engine to tap any fuel tank. This meant the engines would never starve, a capability that had claimed countless German pilots who flew machines with more primitive arrangements. Every design choice reflected an overriding commitment to keeping the aircraft flying, regardless of manufacturing complexity. Schmidt found himself filling notebook after notebook with weight figures that seemed to defy basic logic. The electrical installation alone outweighed everything in a BF-109's instrument panel, yet it delivered capabilities German fighters simply didn't possess. Navigation radios with automatic direction finding, communication systems linking pilot to ground crews, firing circuits integrated with gun cameras. The weapons arrangement presented a fundamental philosophical contrast that Schmidt couldn't ignore. German doctrine scattered armament throughout the fuselage. Machine guns here, cannons there, ammunition distributed to maintain balance. The Americans did something radically different. They consolidated every weapon into the nose section, 4.5 caliber machine guns and one 20mm cannon, all firing straight ahead with perfect alignment, no convergence issues whatsoever. Schmidt studied the ammunition feed systems and found himself genuinely impressed by American manufacturing standards. Power-driven feeds eliminated the belt systems German aircraft relied upon. The cannon featured a motor-driven mechanism that automatically cleared blockages. This wasn't just engineering. It was manufacturing sophistication that German factories simply couldn't achieve in wartime production. The structure beneath the skin revealed the deepest philosophical gulf between these two design philosophies. German engineers had minimized weight ruthlessly, using thin aluminum and tight safety margins. The P-38 took the opposite approach entirely. Redundancy permeated every structural element. Twin main spars supported each wing. Multiple load paths distributed forces through the control cable systems. The engine mounts were designed to contain catastrophic engine failure without compromising the airframe. Brenner's stress calculations confirmed what Schmidt was beginning to understand. American designers built in survival margins at every level. An engine could fail, and the aircraft would still fly. Cannon rounds could strike non-critical areas, and the structure would hold. Multiple systems could malfunction simultaneously, and backup networks would maintain control. Yet the weight penalty seemed incomprehensible by conventional standards. The P-38 tipped the scales at over 15,000 pounds empty, compared to just 6,000 for a Bf-109G. American engines produced less horsepower per pound than German power plants. Two engines, however, overcame this disadvantage through sheer force and redundancy rather than elegant efficiency. Schmidt closed his notebook as afternoon light slanted across the hangar floor. 3 weeks of detailed analysis had exposed an aircraft that shouldn't exist, according to everything German aviation understood about fighter design. Too heavy to climb efficiently, too complicated to maintain in field conditions, too expensive for mass production. Yet captured American test data proved the Lightning dominated in every performance metric that mattered. The truth was becoming inescapable. American aviation had solved fighter design challenges not through engineering elegance, but through industrial abundance, creating capabilities that German precision simply couldn't match, despite theoretical superiority. Hans-Werner Löscher, Germany's most celebrated test pilot with 2 decades and 120 different aircraft in his logbook, settled into the P-38 Lightning's cockpit with the methodical focus that had kept him alive through countless missions. June 25, 1943 would be his first real encounter with American fighter philosophy. Löscher brought scientific objectivity to every evaluation. His flight reports never allowed nationalism to color his assessments, a reputation that made his evaluation of the Lightning's performance capabilities absolutely critical for Luftwaffe command. The cockpit layout immediately challenged everything he knew about pilot workspace. In the Bf-109, controls clustered naturally within arm's reach. The P-38 distributed systems across multiple panels with automatic functions designed to reduce pilot workload during critical moments. The turbocharger controls caught his attention immediately, or rather their absence. American engineers had automated boost pressure management through self-regulating wastegate systems that maintained optimal power without pilot intervention. Engine startup procedures revealed the American design philosophy through mechanical complexity designed to ensure reliability. Twin Allison V1710 engines each required individual startup sequences. Electric starters, automatic mixture management, and oil dilution systems prevented the cold weather starting problems that plagued conventional fighters. German aircraft demanded pilot technique to manage engine parameters. The P-38 managed itself through engineering systems that compensated for human limitations. Löscher advanced the throttles and felt the Lightning surge down Recklin's main runway with authority that exceeded anything German in his experience. The tricycle landing gear eliminated ground handling problems that damaged conventional fighters during taxi operations. Counter-rotating propellers prevented the torque roll that killed inexperienced pilots during takeoff. At 90 knots, Löscher eased back on the control stick and the P-38 lifted cleanly into the morning air. Controls responding with immediate familiarity despite its unconventional layout. The climb test would provide definitive altitude performance data to validate American claims. Löscher established steady climb at 160 knots, monitoring temperatures and pressures as the Lightning ascended through German fighter operational ceiling. At 6,000 meters, the altitude where Bf-109 performance degraded noticeably, the P-38 engines maintained full power through turbocharger boost that German systems couldn't replicate. Reckland control, Lightning test aircraft passing 8,000 meters, climb rate still 400 meters per minute, Löscher transmitted, professional amazement evident beneath the radio static. German doctrine assumed effective combat occurred below 7,000 meters, yet the American fighter continued climbing with undiminished strength toward altitudes where Luftwaffe interceptors struggled. At 10,000 meters, Löscher leveled off and began systematically evaluating systems German engineering had dismissed as unnecessarily complicated. Turbo superchargers maintained sea-level manifold pressure despite air density that would suffocate conventional engines, while intercoolers built into the wing leading edges prevented detonation problems that limited German high-altitude operations. Speed runs confirmed performance figures Luftwaffe intelligence had dismissed as propaganda. At military power, the P-38 achieved 420 knots true airspeed at optimal altitude, significantly faster than any German production fighter. More critically, twin engines eliminated single-point failure modes that made German single-engine designs vulnerable. Lightning test aircraft, execute maximum rate dive to evaluate structural limits, came the transmission from Schmidt's team. The request carried unmistakable weight. German fighters suffered structural failures during high-speed maneuvers that American aircraft apparently survived through superior engineering margins. Rolling inverted, Lercher pointed the nose earthward and watched the airspeed indicator climb past 400 knots indicated. German dive tactics rarely exceeded 350 knots due to structural limitations. The P-38 continued accelerating through speed ranges that would destroy conventional fighters. At 460 knots indicated, aerodynamic phenomena German aviation had never encountered suddenly transformed the responsive fighter into an uncontrollable projectile. Compressibility effects, the precursor to supersonic flight, incompletely understood at that moment, locked the P-38's elevator controls in neutral position as shockwaves formed across the wing surfaces. Lercher found himself captive in an aircraft plummeting toward Earth at terminal velocity. Controls welded in place regardless of pilot pressure. The altimeter unwound through 5,000 meters, 4,000, 3,000. Lercher applied maximum back pressure to controls that wouldn't respond. Only decades of test flying suggested salvation. As air density increased during descent, compressibility effects gradually diminished until elevator authority slowly returned below 2,000 meters. Lercher arrested the dive barely 500 meters above Recklin's tree line, the Lightning pulling out of its death descent with loads that would have torn apart any German fighter. Reckland control, Lightning test aircraft recovering from uncontrolled dive, Lercher transmitted, controlled tension audible in his voice. American aircraft encounters compressibility limitations at 460 knots indicated, but structural integrity remains intact throughout recovery sequence. The post-flight briefing exposed uncomfortable truths about German aviation limitations compared to American engineering capability. Lercher's report documented performance advantages that couldn't be dismissed. Climb rates exceeding German fighters by 30%, service ceilings 2,000 meters higher than Luftwaffe limits, structural strength allowing survival of flight conditions no German pilot had experienced. More significantly, the P-38's compressibility problems revealed American aviation was pushing into speed regimes German engineering hadn't even contemplated. The Lightning represented not current superiority alone, but exploration of aerodynamic frontiers that would define the next generation of military aircraft. Lercher's final assessment carried the authority of Germany's most experienced test pilot. American fighter technology exceeds our current capabilities in every measurable category except maneuverability at low altitude. Oberingenieur Wilhelm Schmid arranged 3 weeks of test data across the oak table in Recklin's conference room on July 8, 1943. The moment had arrived when German aviation leadership would confront evidence challenging every assumption about fighter design philosophy. Senior Luftwaffe engineers filled the chairs around him, men whose careers rested on the certainty of German technical superiority, who viewed enemy equipment as inferior engineering disguised by industrial scale. Schmid began with manufacturing analysis that immediately disrupted comfortable assumptions. The P-38 unit production cost reaches $120,000 American compared to $85,000 for our Bf-109G. However, current American production achieves 15 P-38 aircraft daily, while we manage 12 Gustav variants. The numbers extended far beyond cost accounting. American industry could afford mechanical complexity because sophisticated manufacturing processes German factories simply couldn't replicate under wartime conditions. General Major Kurt Student, Recklin's technical director, interrupted with the institutional skepticism that had guided German aviation development. Higher cost typically indicates inefficient production methods, not superior engineering. American industrial practices emphasize quantity over precision, exactly what we would expect from mass production philosophy. The students' dismissal revealed deeply ingrained beliefs about German technical superiority that had influenced Luftwaffe purchasing decisions since 1939. Schmid pulled out his performance data sheets and proceeded with flight test results that painted a very different picture from what the students had suggested. Lurch's evaluation confirmed American performance claims across every single measure. Service ceiling reached 11,300 meters compared to the Gustav's 9,800 meters. Maximum speed at altitude hit 670 kilometers per hour versus 610. But the most striking figure was combat radius with internal fuel, 2,250 kilometers compared to just 640 for German fighters. Those range numbers represented a strategic shift that German military thinking had simply failed to predict. Luftwaffe fighter tactics had always centered on short-range interception missions, with aircraft operating within just a few hundred kilometers of their home bases. The P-38's operational radius changed everything. American fighters could now escort bomber formations deep into German territory, providing protection throughout entire missions that German interceptors couldn't touch due to fuel constraints. Oberst Heinrich Bover, chief of fighter development, studied Schmid's structural analysis with mounting concern. These weight figures simply cannot be accurate. An operational weight of 15,000 pounds represents a 40% penalty against our single-engine fighters. No aircraft can overcome such a handicap through raw engineering power. Bove had overseen German fighter development since 1938, building his career on weight optimization that squeezed maximum performance from minimal structure. Schmid turned to his metallurgical findings, which revealed American manufacturing capabilities that far exceeded anything Germany could produce during wartime. The aluminum alloy specifications surpass our current standards in both tensile strength and fatigue resistance. The engine mount structures utilized stress-relieved forging that we simply cannot replicate with materials available to us. Beyond that, structural redundancy provides operational survivability through multiple load paths. A single hit that would destroy a German fighter merely degrades P-38 performance without stopping the mission entirely. The philosophical conflict became clear as Schmid presented his most uncomfortable findings. German aviation had pursued theoretical perfection through weight minimization and mechanical simplicity, building fighters that performed brilliantly under ideal conditions but failed catastrophically when systems pushed beyond design limits. American engineers had accepted weight penalties and added complexity specifically to ensure operational reliability under combat conditions that German doctrine had never contemplated. The students' response reflected institutional resistance to concepts that would demand fundamental reorganization of German industrial priorities. Complexity brings maintenance headaches that will cripple American logistics systems. Our streamlined designs guarantee operational availability through reduced maintenance demands and faster production cycles. Our pilots compensate for equipment limitations through superior training and tactical skill. Lurch's flight test report contradicted the students' claim with concrete data that couldn't be argued away theoretically. Twin-engine configuration provides complete backup for critical systems. Losing an engine merely reduces capability, while losing an engine on German single-engine fighters leaves them as gliders. Hydraulic failure affects only secondary functions on the American design, whereas German fighters lose flight control entirely. The P-38 continues fighting with battle damage that would force German pilots to abandon their aircraft immediately. The strategic questions extended far beyond individual aircraft performance toward broader concerns about how industrial warfare should actually be prioritized. Schmid's cost analysis showed that America could afford to build fighters using technologies that German production couldn't possibly replicate. Precision turbo superchargers, automated flight controls, redundant electrical systems, and structural materials requiring manufacturing processes beyond German industrial capacity under wartime constraints. Bove studied ammunition capacity figures that highlighted yet another American edge. 409 rounds per minute combined firepower from nose-mounted weapons, zero convergence issues, no ammunition feed complications from scattered weapon positions. They have engineered their way past fighter armament problems using resources we cannot match. German fighters scattered weapons throughout the fuselage to maintain balance, creating complicated ammunition systems that frequently jammed during aggressive combat maneuvers. The fundamental truth emerged through careful comparison of design philosophies rather than isolated technical details. German aviation had built fighters optimized for theoretical performance under perfect conditions, creating aircraft that excelled in specific situations but struggled when operating parameters exceeded narrow design boundaries. American engineers had optimized for operational effectiveness under real combat conditions, willingly accepting theoretical drawbacks to guarantee mission success regardless of battle damage, pilot skill level, or environmental challenges. The students' final assessment revealed institutional unwillingness to face strategic implications that would demand massive industrial reorganization. We should increase production rates for existing designs. German engineering principles remain fundamentally sound, and apparent American advantages stem from temporary industrial scale rather than superior technical thinking. We cannot justify comprehensive retooling based on captured enemy equipment. Schmid closed his portfolio, knowing his technical evaluation had documented American aviation superiority that German leadership would simply refuse to acknowledge. The P-38 Lightning represented far more than just an advanced fighter aircraft. It embodied an industrial philosophy prioritizing operational effectiveness over theoretical elegance, reliability over weight minimization, and pilot survivability over manufacturing simplicity. This war would be decided by engineering principles that German aviation had rejected as wasteful inefficiency. September 13, 1943. Wilhelm Schmid sat alone in his Rechlin office as afternoon shadows lengthened across technical drawings representing 3 months of the most thorough aircraft evaluation in Luftwaffe history. His completed final report to Berlin sat on the desk, 47 pages of performance data, structural analysis, and strategic assessment documenting American aviation supremacy, with mathematical precision no one could dismiss through institutional bias or nationalist pride. The numbers told an uncomfortable story about German aviation's fundamental misreading of what industrial warfare actually demanded. American P-38 production had reached 200 aircraft monthly while maintaining quality standards exceeding German peacetime manufacturing tolerances. Each Lightning incorporated technologies that German industry could not replicate even under optimal circumstances. Precision turbo superchargers requiring metallurgical expertise beyond Luftwaffe supplier capabilities. Automated flight controls employing servo mechanisms unavailable to German manufacturers. Electrical systems featuring redundancy levels that tripled production costs without apparent concern for resource efficiency. Schmid reviewed performance comparisons, revealing systematic American advantages across every meaningful fighter capability. Combat radius: 2,250 kilometers versus 640 for German fighters, fundamentally altering air warfare strategy. Service ceiling: 11,300 meters versus 9,800, providing altitude advantage that German interceptors couldn't overcome through tactics alone. Maximum speed: 670 kilometers per hour versus 610, building performance margins accumulating through extended combat engagements. Yet pure performance numbers failed to capture the Lightning's most revolutionary trait: operational reliability, allowing average pilots to achieve mission success rates that German aces reached only through exceptional ability and luck. Twin-engine redundancy eliminated single-point failures, routinely killing Luftwaffe pilots, while automated systems compensated for pilot limitations the German training doctrine addressed through extended preparation and careful recruitment. The strategic assessment contained conclusions challenging German aviation doctrine at its core assumptions about air combat needs. Luftwaffe fighter development had optimized aircraft for short-range interception within established defensive parameters, creating fighters excelling in specific tactical moments but failing when operational parameters exceeded narrow design boundaries. American aviation had developed fighters for strategic missions requiring sustained performance across extended ranges, accepting theoretical drawbacks to ensure operational effectiveness under combat conditions German doctrine hadn't anticipated. Schmidt examined captured American training manuals, revealing philosophical differences extending beyond technical specifications toward fundamental concepts about pilot-aircraft relationships. German flight training emphasized individual skill development, compensating for equipment limitations through superior airmanship and tactical expertise. American training assumed average pilot capabilities and emphasized procedural compliance, using aircraft systems to overcome human limitations through mechanical sophistication and automated redundancy. The manufacturing analysis documented American industrial capabilities, rendering German production advantages obsolete through technological advancement rather than simple scale increases. Lightning production facilities incorporated precision manufacturing processes that German industry had achieved only in specialized fields. Investment casting for turbo supercharger components. Automated assembly techniques for electrical systems. Quality control standards eliminating manufacturing defects through systematic inspection rather than post-production repair procedures. Intelligence reports from captured American aircrews revealed operational doctrines explaining P-38 design priorities with troubling clarity. American strategic planning anticipated extended air campaigns requiring fighter aircraft capable of escorting bomber formations throughout missions lasting 8 to 10 hours over distances exceeding 3,000 kilometers. German defensive strategies had assumed short-range interception would prove adequate against bomber formations operating from conventional fighter range. The Lightning's armament arrangement represented American solutions to gunnery problems that German aviation had accepted as inherent fighter design limitations. Nose-mounted weapons eliminated convergence complications that reduced German fighter effectiveness beyond optimal engagement ranges, while power-driven ammunition feeds prevented feeding failures that routinely ended German combat engagements during critical moments. Combined firepower exceeded 400 rounds per minute from weapons remaining effective throughout the aircraft's operational envelope. Schmidt's personal transformation from institutional advocate to reluctant realist reflected broader German aviation industry recognition that American engineering philosophy had solved fundamental problems through approaches contradicting established European design principles. The P-38 succeeded not despite its complexity and weight penalties, but because American engineers had correctly identified operational requirements that German doctrine had either ignored or dismissed as theoretically wasteful. Weather reports from the Russian front provided stark context for German fighter limitations that American redundancy eliminated through engineering rather than pilot expertise. Luftwaffe squadrons reported 50% operational readiness during winter operations, as single-engine fighters suffered mechanical failures that twin-engine American aircraft would survive through backup systems. German pilots ejected from aircraft experiencing engine problems that P-38 pilots considered routine inconveniences requiring single-engine flight procedures. As September daylight faded across Russian airfields, Schmid observed a Bf-109 formation returning from combat patrol with 2 aircraft missing and 1 streaming smoke from engine damage requiring immediate replacement. The same mission flown by P-38 squadrons would likely result in complete formation return, with damaged aircraft continuing operations through redundant systems that German fighters couldn't provide. Schmid's final report entry captured the strategic reality German aviation leadership would refuse to acknowledge. American aviation industry has produced fighters designed for industrial warfare requirements rather than traditional air combat doctrine. The P-38 Lightning represents systematic engineering solutions to operational problems that we have addressed through pilot training and tactical adaptation. In extended strategic combat, engineering advantages accumulate faster than training advantages can compensate. The captured Lightning would remain at Rachlin as a technological monument to American industrial philosophy that had redefined military aviation through abundance rather than efficiency, redundancy rather than elegance, and operational reliability rather than theoretical perfection. German engineers had asked for optimal performance under ideal conditions. American engineers had delivered effective performance under any conditions war could impose.